Awesome. Thank you very much. So I'm going to be speaking on this idea of operating at a snowdrift resolving scale. So high mountain models, they need to account for the substantial heterogeneity and spatial and variable mass and energy fluxes. And so getting after this heterogeneity really motivates the snowdrift resolving scale at tens of meters to a couple hundred meters. And with satellite data assimilation, these models can provide accurate and timely forecasts of really important processes in cold regions, especially when there are observation-sparse regions being investigated. And when driven with dynamically downscaled climate model data, these models can then provide really crucial data and socially relevant diagnostic information for future mountain Earth systems, and specifically at the scales that the users need. So just on the right here, the figure showing large heterogeneity in snow cover as derived from LiDAR observation in the Canadian Rockies. So the Canadian Hydrological Model, CHM, is an approach to go after modeling at these scales. And it does so using a variable resolution landscape representation. And it can be conditioned on topography, soils, vegetation. So these really important surface processes are well represented. But it leads to large decreases in the computational and data demands versus traditional rectangular gridded models. The CHM includes algorithms for downscaling the meteorology, as well as including historically accurate in situ stations. CHM currently accounts for slope, aspect, terrain shadowing, gravitational redistribution, blowing snow, snow canopy interactions, as well as energy balance models. And so this allows for a really globally applicable model using existing data sets. So just an example of what this variable resolution looks like. This is kind of a high resolution example, but you can see a mountain topography that the mesh is being conditioned to, as well as a vegetation layer. And so you can see the tree line is well represented, the streams are well represented, so it allows you to have heterogeneity and the snowdrift resolving scale where appropriate, but at significant computational decreases. So an example of the importance of including these types of processes in a multi-scale model, I'd like to show you this influence of snow redistribution, and so this is in the Canadian Rocky Mountains. On the left is a LiDAR-derived snow depth map, and you can see a lot of heterogeneity, and just calling your attention to the red areas being avalanche deposition, and the purple being wind redistribution along crest lines. If we run CHM without including these processes shown in the middle, the heterogeneity that's observed is not present. However, when these processes are enabled, so the snow redistribution and a kind of a simplistic vertical redistribution, the heterogeneity that we observe in the snow cover that we know impacts the hydrology is something that becomes representable in the models. Taking advantage of modern high-performance computing paradigms, as well as this unstructured variable resolution approach, we can scale up to very large spatial extents. So this is showing a 1.3 million square kilometer simulation for 4 days over Western Canada. This is using a 2.5 kilometer numerical weather prediction output from a Canadian weather prediction. And what we're seeing here is just a simple simulation, and the figures zoom in to a higher resolution, showing that we're capturing these ridge lines, we're capturing this snowdrift resolving scale in this unstructured way in a very computationally efficient manner. So the outlook going forward, the phase one is to run CHM for all of Canada, including more data assimilation. And this includes improvement of a snowcast product that we've been developing. This is a quasi-operational 2- and 6-day forecast of snow depth, snow water equivalent, and density that we provide for a portion of Western Canada. We'd like to extend that in phase two to Global Water Future at the University of Saskatchewan's international partners, primarily through GWEX and ARCH to begin with. And this will be targeting areas such as the Andes, High Mountain Asia, and the North American Cordillera. In parallel to this is the development and incorporation of a full hydrological cycle into CHM that will further enable the global application. Thank you very much.
Thank you, Chris. Our next and final speaker for this panel